So a length of metal rod is being put into a rectangular box. The important thing to remember, so we're trying to put as long a section of rod in there as we can. The important thing to remember that when you have a three-dimensional figure, the longest dimension that you can put in there is a diagonal from one corner to the opposite corner. So from the top back to the opposite front corner. In order to find that diagonal, we need the dimensions of the box, all three dimensions. Statement 1 gives us that it's 20 inches long and 12 inches wide, but it doesn't give the third dimension, so that can't be sufficient, and neither can answer choice D. Statement 2 tells us that the volume of the box is 1200, but that doesn't give us the actual dimensions, and a 10 by 10 by 12 box would be very different from a 1 by 12 by 100 box. Obviously, the one with a single dimension of 100 will allow for a much longer diagonal. Not knowing which is which, we can't accept that statement as sufficient. So then we are left considering the two in conjunction, knowing that it is 20 by 12, and we know that the total volume is 1200, so we know that we don't even have to do the math. A dimension of 12 by a dimension of 20 times whatever that third dimension is equals 1200. We could solve for x, that gives us the third dimension, and from there we could go through the fairly long process of using the Pythagorean theorem twice to find out what that length of the internal diagonal is. We don't need to actually do it, we just know that once we have all three dimensions, we can find the diagonal of the base, and then use that to find that internal diagonal. So the two statements together are sufficient. Answer choice C.